A little while ago, Spotify recommended me this new artist. I think her name was Chappelle Rowan, and she's really good. And I was like, oh my god, I discovered this new artist. She's incredible. Okay, well, that's kind of what happened, and then I realized I did not discover her. Not at all. I recently watched Chappell's SNL Performance, and I cried. I full-on cried. And I'm not sure why, but I did. And that's why my face is not in this video. I cried so much that my makeup is just gone. So, no video today. Now, I went on YouTube and I searched Chappell Roan, as I'm sure many boomers did after that performance on SNL, and I scrolled for a while to look at the videos that popped up when I googled her name. I took note of two things. First of all, how many months has the video been on YouTube? And second of all, how many views does it have in millions? Because Chappell Roan has millions of views. As you can see, there's a trend here other than this one point, and yes, you guessed it, that is Hot to Go. 32 million views on that video. I didn't cry when I watched that one, but I probably could have. So as you can see, a general linear trend here. Other than Hot to Go, we have a really strong pattern. Now, because of Hot to Go, the R value here is 0.558. So if we take out that one data point, this could probably be a lot stronger, but we're going to leave it in because it's Hot to Go. It's got to stay in. Our explanatory variable is the time that the video has been on YouTube in months. The mean time on YouTube for these videos was 9.8. and the standard deviation was 12.9. As you can see, there was this one video that's been on a long time, but a lot of these have recently come out in the last half a year. The response variable is the number of views. The mean number of views for Chappell's videos are 7.7 million, standard deviation 8.7. Now Hot to Go is dragging that mean up quite a bit. As you can see, most of these are clustered around 5 million, and the Hot to Go video is definitely pulling that mean upwards towards 7.7. The line that I have drawn here is the Least Squares Regression Line. It's the line of best fit. There's one feature of the Least Squares Regression Line that we haven't talked about yet, and that fact is that there's one point that will always be on the Least Squares Regression Line. The point that's always on the Least Squares Regression Line is x mean, comma, y mean. Sometimes we call this x bar and y bar, and it's just a little bar on top of the x and y. Let's see if that's true for this Least Squares Regression Line. So let's see, 9.8 is about right here. I go straight over. Wow, look at that straight line. Yeah, that's about at 7.7. So that's always true of any least squares regression line. There will always be a point on the line that is equal to the mean of x, the mean of y. Okay, I need to adjust the lighting in here. That's the real reason there's no video. It's daylight savings, and I forgot that there wouldn't be as much sunlight right now as there normally is, and so it's very dark in here. Hold on. Now there's one other feature of all least squares regression lines, and that is the formula for the slope of the line. The slope of the least squares regression line is the correlation coefficient, so r, times the standard deviation of y over the standard deviation of x. Now for this video, we're not really going to get into it, but we are going to calculate the slope. So our correlation coefficient was 0.558, standard deviation of y was 8.7, standard deviation of x 12.9. All right, now I gotta find my calculator. Oh man, it took me forever to find my calculator. My room is a mess. I got attacked by a goose earlier. Like, it just attacked me out of nowhere, and now I have a black eye. That's why I'm not putting my face in this video, actually. Okay, so I finally finished that calculation. The slope is 0.37. So this formula for slope will always work if you need to find the slope of the least squares regression line. Now, if you need to find the equation as a whole, you've got the slope and you've got a point. So you can use point-slope form. Y equals mx plus b's less popular cousin. So here's how this works. You leave the y and the x alone, but you plug in everything else. So we plug in the slope we have, 0.37. We plug in a y value that we know, so that'd be 7.7. And then we plug in an x value that we know, and that's 9.8. Now, technically this is the equation of the line, but we could do a little bit of algebra and rearrange it so that it's in y equals mx plus b form. So first I'm going to distribute the 0.37, and I'm going to run out of room, and then I'm going to add 7.7. You can really tell that I planned this out, huh? And there we go, there's our least squares regression line. So sometimes you're given the least squares regression line, like from a computer or like StatCrunch or Statplet or something, but sometimes you can find it by hand just by taking all these different pieces and putting them all together. Now, if you'll excuse me, I need to go find that goose and get some revenge.